Hi, everybody. So welcome back. This is workshop 2. We're going to be building off some of the original concepts that I introduced in workshop 1. And what we covered, just as a reminder, is the basics of case interviewing. What is a case interview? What are you expected to know? Why do interviewers and why do organizations use this interview tactic? And we're going to build on some of that today and talk a bit about the mathematics in a case interview, so the analytical side of a case interview. And workshop 2 today is a bit shorter, and we're just going to work on building off estimations and graphical analysis. Similar to workshop 1, I want to caveat that for some students, this might be very familiar. And that's okay. This will just be review and practice for you. In other cases, there may be things here you haven't seen before, and that's also okay. What we want you to do is just make sure that you jot down all your questions and feel comfortable reaching out to your career coach with any remaining questions you have. We want you to be very comfortable with this material going into your interviews. So our agenda today. We're going to start off with the basics. So just talking about some of the primary things you need to know when approaching the analytical side of a case interview. We're going to go through a handful of estimation strategies. Now, I want to say that these are just a handful of strategies, and these are definitely not exhaustive. Similar to a lot of learning techniques, there are going to be some strategies that work for some students and some strategies that work for other students. This is not a one-size-fits-all, so please use what works for you, and if nothing that we present to you today works for you, feel free to research other strategies that might be more effective. We're also going to go through calculations, so I introduced a couple key calculations in the first workshop, and we're going to go through them again and talk a little bit more about how they might show up in a case interview. Then we're going to go into graphical analysis. It is not unusual for a graph of some sort to show up within the context of a larger case interview. We don't want students to be taken back by this, and a lot of the graphical analysis is about synthesizing key information and identifying that key information. So we'll go through a few simple examples. And then I'm going to talk a bit about common mistakes that students make. And the reason we bring this up is just to make you aware of what common pitfalls of the analytical process can be for students, so that you all can avoid that. So jumping right into the basics. 101 of math within a case interview. You do not bring a calculator to a case interview. The expectation of the interviewer is that any of the numbers or calculations that they present to you or ask you to complete are things that you should be able to do either in your head or on paper. So everything you should be able to do by writing it down with a pen and paper. To that point, we say bring graph paper to do your calculations. And we suggest this for a few reasons. One, we think it keeps students much more organized, and that's very important, especially if you're going through a 45-minute case interview and have to refer back and forth to different sections of the case or different questions you've already answered. The other reason is, on rare occasions, some companies actually ask students to graph something based on a set of data they hand them. This is not necessarily a common thing, but it's happened from time to time, so we want students to be prepared for that. We want to highlight that you should not rely on doing calculations solely in your head. Even if you are incredibly fast and typically accurate with arithmetic, you may be very nervous and you may make a silly mistake, and that's the last thing you want to do. I one time interviewed a student that was a very, very strong math student and asked them what 10 times 200 was, and they shouted out the answer, 20. And it was just too fast. It was a nervous reaction, and that's what you want to try to avoid. So make sure you're writing down those calculations. For some of our students that are less analytically inclined, we actually suggest that they write the words down. So if, for instance, I'm asking you about a profit situation, writing down profit equals revenue minus cost, and then going into numbers. For some reason, that helps baseline a lot of students. So if that works for you, feel free to use that strategy. Practice your mental math. You are now college students, so it's probably been a while since you've been doing math without a calculator or very basic arithmetic. Try to practice some of these things. Bring out your flashcards if that helps you. And be prepared to answer the question, how are your analytical skills? It seems like a very basic question, but they're looking to, one, see if it's something that you're willing to say is not your strongest point, but you feel comfortable with basic calculations, or two, show with confidence that you do have strong analytical skills, and then be willing to back that up when they move into the analytics in a case interview. So I'm going to walk you through just a handful of estimation strategies, as I mentioned before. These are by no means exhaustive, and these are just a few percentage examples to help you deal with numbers a bit more easily. So this first example, 9 is what percentage of 72? This often happens in the early stages of a case interview process. So oftentimes when you're interviewed, you're not only interviewed with one case. Sometimes you'll have to go through a process where you will come in to interview and have to complete multiple cases. So this tends to happen up front. So X is what percent of X? Here our suggestion is always simplify. So make sure that when you're presented something like 9 out of 72, you're simplifying that down to 1/8. Now the second step or strategy that's really embedded here, and sometimes this is a complicated concept for students to grasp, and sometimes this is very natural to the students that are heavier in the math section, is making sure you do the conversion up front for that percentage. So for example, 1 divided by 8 means that you would need to use a decimal place, and it means that you would need to be working in fractions. Whereas here, if you put what is 100 divided by 8, you actually get to work with a number like 12.5, and then you don't have to do the conversion to percentage on the other end. This is very confusing for some students, so if you find that to be the case, you do not have to use this, but it's just one example of a strategy. The next example builds on what I just presented, but it's really breaking down a question into its components. So 3 is what percentage of 17? That's the same as saying 1 is what percentage of 17 and multiplying that by 3. So using that same strategy of saying 100 divided by 17 equals 5.8. So 1 would be 5.8% of 17, and then multiplying that by 3 to get that 17.4%. Possibly a better example and a more simple example would be if somebody is asked to give 30% of a number. 10% is very easy to come to by just moving the decimal place over. So a student might just take 10% of the number and then multiply that by 3. So breaking down a question into its components to make it a bit easier to handle. This is a situation, this example here, that you're seeing 37,000 multiplied by 500. And the reason we present this example is sometimes you're working with very large numbers and they typically get a bit clunky. And if you have a lot of numbers that you're trying to analyze or you're trying to multiply, students tend to either lose or add a 0. So one suggestion we have is to drop the zeros when you're doing the calculation. So in this case, to just do 37 times 5, which gives you 185, and then add the zeros back at the end. So here we have 3 from the 37,000, and we have 2 from the 500. So that gives us 5 in total that we add to the back end of that 185. And that's just to make sure that when you're dealing with very large numbers, whether it be the profit of a company or whether it be the amount of things that they produce, you aren't losing a 0. And this is another example. So what is 9% of 63? You're going to be often asked to estimate things. So a very, very close estimate to 9% of 63 would really be using the baseline of something like 10% of 60. So you're using much more manageable numbers that are close to the numbers that are given. And then you need to make an estimation based on the adjustments that you made. So in this example, 9% of 63, we're going up in our percentage, but we're going down in the number that we're taking it from. So we get 6 but we know that in actuality it's probably a bit lower than that. So we could get very close to the actual by just using estimation strategies. Again, if none of those work for you, feel free to continue to research and practice methods that do work for you, but we wanted to just throw that out there. Oftentimes when you're interviewing, consultancies are looking certainly for your accuracy, but a bit for your speed. We want to highlight that accuracy is most important. So if you're slower at the calculations, that's fine. Take your time, write out your solutions, and explain to the interviewer how you're getting to that solution. So if a calculation takes many steps, make sure they understand which steps you're taking. But at the other hand, it's also important that you not be taking too prolonged a period of time to answer things that an interviewer might consider a fairly basic math question. So practice your speed a little bit. The more you practice, the faster you're going to get. So I just want to rehab some of the calculations that I introduced in the first workshop. These come up time and time again, and I called them out because I just see them across the board in almost every case in some form or fashion. So we have the break-even analysis. We have fixed and variable expenses. Those are terms that you should be very familiar with. We have the difference between net and gross profit margin. So understand the idea of a profit margin and also understand the difference between a net amount and a gross amount. Return on investment, this is a very key calculation. So what is the return on the input that's being made? Opportunity costs and sunk costs, these are things that come up. What is the opportunity cost of a certain business decision? And then is this a sunk cost? Is this a cost we no longer need to consider because the expense has already been incurred? Make sure you're familiar with that. On the other side here, we have compound annual growth rate, product life cycle, elasticity, financial statement analysis, and percentage change. So these are other things that you might see come up in your case interviews. Be familiar with these terms and have an understanding of where they might fall. Now we're going to walk through just an example calculation or two. These are fairly simple examples, and I want to highlight that, but oftentimes the math that is shown in a case interview or that is used in a case interview is not that complicated. They're not really testing your advanced analytical skills. They're testing your basic analytical skills. So things like this might be embedded in a larger case or be one part of a larger calculation. So the question we have here is, the price of stock X has been $27. Due to a poor performance in the last quarter, the stock has dropped to $12.50. What is the percentage change in the stock price? This is a very common question, and it makes the assumption that the student understands that percentage change is the change, so the delta, over the original amount. It's a very important equation for you to know and to memorize, and you'll use it time and time again, whether it be percentage change in revenues or sales. You will see this at some point. So in this case, the delta is 14.5, and the original amount is 27. So the percent change is 53.7. Now, note here that I didn't say negative 53.7. They're asking for a percent change. You could say that it's dropped by that percentage, but percent change is really an absolute value. Another simple example, and the reason we chose this one is because it has to be broken down into several different components, and you'll see what I mean when we bring up the answer here in 1 second. Every 5 minutes, an American man is diagnosed with prostate cancer. How many American men will be diagnosed this year? So you have some information, so you know that every 5 minutes someone's diagnosed, and then they're asking about how many would be diagnosed in a year. You have to really break this down into different components. How many minutes are in an hour? How many hours are in a day? How many days are in a year? So once you break down these components, you see that it'll be 12 men per hour, 12 men diagnosed per hour times 24 is 288 men per day. 288 men per day times, of course, 365 days equals your answer. And it's very important here to remember your units. They may be asking a question in terms of seconds, minutes, hours, and one of the inputs they give you or one of the components they give you to help you solve the question is in a different unit. So you need to make sure that your units are matching. And in an example like this, that's a multi-stage problem, it just helps keep you organized and stay on track. So now we're going to move away from just the solid calculations to talk a bit more about graphical analysis and how that shows up in the case interview. Most of you have done some sort of graphical analysis, whether it be in a statistics class, which is much more advanced than what you would see in a case interview, or marketing class. But there are three key components to graphical analysis within a case interview. You identify the chart form, you determine what comparison the chart is calling for, and then you need to summarize the message. So here are the three key types of graphs that you're going to come across. And there are certainly other things that you may come across, but these are the traditional three. The first one is, of course, a line graph. What a line graph tends to show you is a trend over time. So for instance, sales over the last few quarters, or how something's changed from year to year. A pie graph, on the other hand, is showing something's relationship to a whole. So my percentage sales as a comparison to the rest of the market or to my competitors. Then lastly, you have a bar graph. This is by far the most common type of graph that you're going to come across within a case interview. And it shows relationships among groups. So it can compare different things. Important for all things is that you need to be able to read the axes. So what is the data that they're capturing? And be sure to call attention, of course, to the title. The title often is loaded with a summary of what the graph is trying to capture. We're going to go through a very basic example of each of these types of graphs, just to give you a sense of what you might see. Now, I want to make the note here, and this is very important. There are times that you will be given graphs or sets of data that are very dense. So you'll get a lot of data at once. Half of that data may not be relevant to solving the case or for moving the case forward. And that's part of the test. They're trying to understand when you're given a set of data or when you're given a graph, can you recognize the most important data points or the most important factors of that graph? And can you recognize what's meaningful and what's not relevant? So what is just filler data that they're trying to distract you with? Sometimes you might even be asked, what's the first thing that stands out to you? Or what's most surprising? Or what impression do you have the second you look at this graph? So be sure you're comfortable answering questions like that. In this example, we start with the bar graph, so the most common type. A bar graph given below shows the sale of books in thousands, very important again to note your units, from 6 branches of a publishing company during 2 consecutive years, 2000 and 2001. So you have a lot of information. Now, sometimes the information is captured in a paragraph that introduces the graph, and sometimes they're only going to give you the graph itself. Make sure you're drawing from both. So take a minute, look at the title, look at the axes, and get a full understanding of what they're trying to present. Then you might get questions like this. What is the ratio of total sales of branch B2 for both years to the total sales of branch B4 for both years? So they've asked you about specific branches. You have to find them on the graph. And then they've thrown in total sales for both years. So you have to do an additional calculation there. The answer is 7/9. So this is just paying attention to what they're really asking you and taking the time to do any additional calculations off the data you can gather from the graph. Another type of question they might ask you is, what is the average sales of all of the branches in thousand numbers for year 2000. Again, this is where units come in. If you've missed in the introduction that it's in thousands, you might present these numbers not in thousands. So in this case, it's 80,000. If you weren't paying attention to your units, you might report the average sales to be just 80. So be careful with that. That's a big red flag to interviewers. Next, we're going to go into a line graph example. So this is not my favorite example, to be quite frank with you, but it's a simple one that will give you a gist of this kind of analysis. The following line graph gives the temperature on various days in January. It's very simple. This one doesn't come without a title, but you would look at the title. Again, you'd look at the axes, and you'd look at the unit. The temperature in the beginning of the week, is it rising or falling? Very simple. Rising. So you see that there's an upward trend. There was the least amount of temperature change between which days? And here, of course, it's 5 and 6. So it's where the slope of the line is the flattest. And again, when you have a flat slope, it's not a lot of change. When you have a very steep slope, it's indicating a lot of change in those numbers. Oftentimes when you're given a line graph, it won't be as basic as this example. You won't only have one line. Oftentimes they'll do things, for example, comparing different companies' sales trends over time. So you might have 4 lines on one graph. And what you're looking to do is call out any outliers, anything that is different from the norm or drastically different from the other lines, and talk about general trends and be able to summarize that data. One thing to note on line graphs in particular, but this applies to all of the graphs, make sure you're not going into too much detail. So for instance, if I were asked to describe this graph, I wouldn't want to go at every increment. So I wouldn't describe from 1 to 2, 2 to 3, 3 to 4, and so forth. I would describe overall trends. So in the first couple of days, it looks like temperatures are rising, with the sharpest increase being at day 4. But then after that, there's a dip until day 5, and then it starts climbing again from 5 to 7, rather than going through every detail. And then lastly, the pie graph. So this is an example. The pie chart below shows the percentages of the world population in each continent. The present world population is about 7 billion. This is a really good example of a time that information that's not directly in the graph may be important to whatever questions you're asked or whatever calculations you have to do off of the data. So in this case, you've just been presented with the information that the world population is 7 billion. That's important because within the pie graph, you only have percentages. So you need to know percentages of what. So a question here might be, how many people live in Africa? Very simple, right? It should be 15% of 7 billion. So it would take you recognizing the information they give you outside of the graph, pulling a basic number percentage from the graph, and doing that calculation. They might also ask you things such as, how many people do not live in Asia? So rather than doing a calculation for how many people live in Africa, how many do not live in Asia? A very simple way to do this would be to take the population in this case that does live in Asia and subtract it from 100%, or subtract it from that 7 billion. And the reason I say this is because if you look at this pie graph, they've asked you how many people don't live in Asia, but then there are 1, 2, 3, 4, 5 other data points on this graph, and it would take you a long time to do the calculations for each of those and add those up. And that's not what they're looking for. They're looking for you to do this quickly. So exactly what we just went through, 7 billion minus the amount that do live in Asia, and that gives us about 2.77 billion. And lastly, how many more people live in North America than in South America? Very common question attached to any pie graph, and it's a comparison. So how many more or how many less? In this case, you can just actually do the difference between the percentages and then multiply that by 7. And then you get 91 million on that. So it's just a different way of doing the math. Some students like to actually do out 7.3% times 7 and then 6% times 7. They feel more comfortable doing that way. But this is another way to do it, and it's a quite quick way to evaluate this third question. So math within the case question. You're going to have some case questions that are very structured. You've been given all of the relevant input, so all of the numbers that you would need, and then you're asked to do a calculation. In those cases, the interviewer is looking for you to be a good listener, to write down the numbers that you were given, and to have an understanding of the calculation. So they're not going to present you with formulas. Those are things that you're expected to bring with you and to know well. Estimations are a bit different. So estimations might be, we'll use the example of a market sizing question. So they might ask you, how many televisions are there in the United States? They know you probably don't have the exact inputs to do a calculation. So you're expected to make estimations. So you might think of how many households there are in the entire United States. And on average, how many television sets are in each household. But at every step of the way, you're being expected to make estimations to move the calculations along. So very important that you make the estimations. If they ask you a question like how many TVs are there in the United States, you can't ask them to give you the numbers. You can ask them if it's acceptable for you to make the estimation. So is it okay for me to make estimations about the number of households? And then it's fine for you to also check your estimations. So I estimate there are about 100 million households in the United States. That's fine, as long as you're checking with them, and as long as you can support your logic. I think this is the case because there are this many people, and traditionally, this many people live in one household. You need to be able to understand why you came to an estimation. Don't just throw a number out. There has to be logic to support it. Write all of the estimations you've made down. And remember, your assumptions must be reasonable. If you say to an interviewer, I think that there are 7 billion households in the United States, but there are 7 billion people in the entire world, it's not a reasonable assumption, and that's something they're going to flag you on. Another thing to note is that your estimation should be easy to deal with numbers. So here I have the example of how many kitchens are there in America? We always use this proxy of households. It comes up time and time again. It's not necessarily the only estimation you'll need to make, but it's a really important one. So number of people in your country and number of households, very important estimations to bring with you. But your estimations should be even numbers, reasonable, and don't make it difficult on yourself. Try to do numbers without decimals. So for instance, you're not going to want to throw out 63 million households because that's a pretty clunky number to have to deal with. You also don't want to be using 80,000 when you could do something like 100,000. And 2.7 million, again, has that decimal point. You want to try to avoid decimal points and fractions where possible, especially when you're the one driving the estimation. So last but not least, a couple of common mistakes that students make. I mentioned this before, but dropping and adding zeros. This is very common. Write it down, double check your zeros. If the estimation strategy that was presented earlier helps you, and you'd like to do the calculations with the zeros dropped up front and then add them all at the end, that is perfectly fine. Just make sure you are writing everything down and keeping yourself organized. This is another example of where mental math and doing everything in your head could cause some problems. Another common mistake is not writing down your calculations and forgetting them later. if they're asking you to do something analytical or do a calculation in the context of a greater case, they are most likely going to have you refer to that later on. At the very least, when you're asked to summarize a case, the calculation and your solution will be an important part of that summary. So if you don't have it written down, it's very likely that you'll forget them. Remember not to confuse percent change with absolute change. Percent change, as I said, comes up time and time again within the case interviews, and it's very different from the absolute change. So the percentage change, obviously, is how much change over the original, where the absolute change is an absolute number, so the actual difference between the two numbers. Don't practice on your own. If you only take away one thing from this entire workshop, this is something that's very important. Practicing math only on your own will make you a bit faster, but it doesn't present the same amount of pressure and realistic scenario that you have when sitting face-to-face with an interviewer. I have a lot of students that come in, they feel very confident, they practice calculation after calculation, but then when they're having to write down the calculation and do it in front of me, they experience something called math freeze, where it's not the difficulty of the problem, it's the pressure of the situation. Practice in front of someone, even if it's your roommate, a family member, or just a friend that you can do this with you. Try it in front of someone. It really does change the way in which you operate. So that's it for this workshop. Again, if you have any questions, be sure to write them down and be sure to reach out to your career coach. If you can't get that answered, feel free to reach out to the Greater Modern Guild team. They will be able to point you to somebody that can answer it. And you'll have a chance to practice all of these strategies, both from workshop 1 and from this workshop in your LMIs. So be sure you're writing down notes and practicing the things that we go over. And otherwise, have a wonderful afternoon or day if you're watching this early in the day. Thanks so much.